Good morning, good afternoon, and good evening. I want us to continue with solution to question 1 given in our previous class. We've solved question number 1, question number 1AB. Now, question number 1C, which we are asked to calculate the percentage of iron in a sample of steel wire if 1.51 gram of the wire was dissolved in excess of dilute sulfuric acid and the solution made up to 250 cm3 in a standard graduated flask. A 25.0 cm3 aliquot, that is, this 25 was pipetted out of 250 in a graduated flask. Okay, and then the volume of potassium permanganate was given as 25.45 cm3 and the mole of potassium permanganate 0.0200 mole per dm3 for a complete oxidation. Solutions. Remember this 0.0200 mole per dm3 of potassium permanganate was the one that was prepared in 1 dm3 or 1000 cm3. Okay, already you know that 0.0200 mole per dm3 is present in 1 dm3 or 1000 cm3. Then you have to find out the moles of potassium permanganate that is present in this 25.45 cm3 before you calculate the mole of iron. Okay, so 0.0200 mole per dm3 of potassium permanganate is present in 1000 cm3, that is 1 dm3. Then x mole of potassium permanganate will be present in 25.45 cm3. If you make your subject, the x, the subject of the formula, we get this. We now have 0.000509 mole per dm3 of potassium permanganate that is present in 25.45 cm3. You can also use formula mole is equal to mole of potassium is equal to concentration in mole per dm3 and multiplied by volume in cm3 over 1000 cm3. Your concentration given 0.0200 mole per dm3 times 25.45 cm3, then over 1000. This cm3 cancel this cm3, multiply this by this divided by 1000, we have this 0.000509 mole per dm3. Now, to get the concentration of iron, from the equation of reactions, we are meant to understand that 1 mole of potassium permanganate reacts with 5 moles of iron. Okay, if 1 mole of potassium permanganate reacted with 5 moles of iron, then the calculated values of potassium permanganate 0.000509 mole per dm3 of potassium permanganate will react with x of iron. If you make your x the subject of the formula, this goes this way and this way, we now have our x is equal to 0.00509 mole per dm3 times 5 mole over 1 mole. This mole cancel this mole, you are left with this multiplied by this, we get 0.002545 moles of iron. This is the mole of iron that is present in the equation from the question. Now, to get the mass To calculate the percentage of that iron, you will first of all calculate the mole, and you convert the mole to mass. You convert the mole to mass. Now, to get the percentage of iron, first calculate mass concentration of iron. Molar mass of iron is 55.9 gram per mole, and moles calculated is 0.002545 mole per dmq. Now, by formula, mole concentration is equals to mass concentration over molar mass. And our mole 0.002545 mole per dmq is equal to mass concentration over 5.9 gram per mole. This one over 1. If you do your cross multiplication, mass concentration times 1, you get this mass concentration is equal to this multiplied by this. So we have this multiplied by this. This mole, cancel this mole. You are left with gram and dmq. So if you multiply this by this, you get our 0.1423 gram per dmq. But remember, the total iron in wire is equal to 0.1423 gram times 10. Don't be surprised where this 10 is coming from. Remember, we're given 250 cmq of graduated iron. The original of iron prepared in 250, and in that 250 you pipetted only 25 and then carry out your titrations. So that 250 is this one, 250 over 25. If you divide this by this, you get 10. This means only 1/10 of the made up solution used in titrations. So you now have the mass concentration calculated multiplied by this 250 divided by this 25 that give us this term. This multiplied by this, we get 1.423 gram of iron. This is the mass of iron calculated. Now the percentage of iron is now percentage is equal to calculated mass over given mass in the question multiplied by 1,000 multiplied by 100 percentage. So our calculated value is 1.423 gram. Here is 1.423 gram over 1.51 gram. Remember this one given from the question. Multiply by 100. This gram go with this gram. You now divide this by this, multiply by 100. You will get 94.2%. This is the percentage of iron from the question given. Thank you.